I'm going to go through this homework fairly quick. Like I have everything typed up. But if you need to slow down and go back and look at it, all of the answers are completely written down in the video that I'm going over, so you can pause it if you need to look at anything more specific. So the first one, the wording of this one was a little vague, which I didn't love. It did talk about, of course I just moved where the paper was. At one point it said statistics classes, but then another one it said just comparing 8 a.m. to 9 a.m. And I didn't love that. And I think I changed the problem a little bit over time. But so this one, I did a specific thing where I did shorthand notation. So I did something as this particular 50-point quiz for this particular statistics teacher. I may have even taken out that was for this specific statistics teacher. I can't remember that. So the wording might be a little bit different, but it's because at one point it talks about classes and at one point it talks about statistics classes. So I wouldn't be that picky about this problem. But in general, you're going to define both. You've got the mean score on the quiz for students in the 8 a.m. You've got the mean score for this quiz of students in the 9 a.m. If you did 8 minus 9, then you would have less than here. Or if you did it the other way around, then you would have mu 9 minus mu 8 and then have greater than here. And either one of those would be fine. And then alpha 0.01. This is a 2-sample t-test for difference in means. T because sigma is unknown. This is where the wording I thought was weird. It just stated it was random sample from both the populations of 8 a.m. and 9 a.m. classes. And it didn't talk about statistics there. That's why I don't love the wording in this problem. But in general, you're still writing that random selection. You're definitely using central limit theorem to check normality. Both of 34 and 31 are both greater than or equal to 30. So by central limit theorem, we can use normal approximation. Independent 10% condition, you're getting 340 for the 8 a.m. and 310 for the 9 a.m. So however you worded it here, match it. So I said students in the statistics class, or in the 9 a.m. statistics class. So I would need mine here to match that, to say, assuming there are at least 340 8 a.m. students taking statistics class. So make your populations match however you chose to do it. But I would probably take either one here because of the wording. So we've got this one. It gave us all the information, so that shouldn't have been too hard. You're just writing it down. Alpha was 0.01. It is a one-tail. Plug in our numbers into the equation, and you should get either negative 2.528 if you did it the way I did it. If you did it as 9 a.m. minus 8 a.m., then you would have positive 2.528. Regardless, you're going to get a p-value of about 0.0073, which is less than alpha. So we reject the null hypothesis, whichever one you did. Since the p-value is less than alpha of 0.01, we do have enough convincing evidence that your alternative hypothesis is whichever one you wrote. Questions on the first problem? Do y'all need me to slow down to go over this, or are we kind of at the point where y'all are okay with me going over it this fast? Okay. I figure at this point you're checking enough to know if you did it right or did it wrong. This one I just typed instead. Again, this is one of those wordy ones. So it specifically says in the third sentence, 100 people with cholesterol levels between 250 and 300 milligrams per deciliter were available for this study. So you need to mention the fact that this is only people with cholesterol levels between 250 and 300 milligrams per deciliter. So I just did some kind of shorthand notation for that. So I said let mu s be the mean decrease in cholesterol level milligrams per deciliter for what I'm defining as people with cholesterol levels between 250 and 300 milligrams per deciliter using the standard cholesterol lowering medication. Now, this is important that it is the mean decrease in, because they did not measure what the cholesterol level was. They measured how much it decreased. So that is definitely important. If you didn't have that written there, you should. And then same thing with the other one, but would be for the new cholesterol lowering medication. If you did standard minus new, so mu-s minus mu-n, the way I defined it, you would have less than. If you did new minus standard, then you would have greater than. Because it's saying the new one, the wording of it says it's more effective, and if it's more effective, it's lowering it by more. So that one's kind of one of those, you've got to think that lowering is good. A higher lower means better. So you've kind of got to think through that one funny. And alpha 0.05 because it wasn't given. So method, 2-sample t-test for difference in means because sigma is not known or given. Stated in the problem that people are randomly assigned to either this one or this one. So you have to explicitly mention, obviously, that it's assigned, but you have to say assigned to either this treatment or this treatment as your written portion. Normal, this is central limit theorem. Both of them are 50, both of them are greater than 30, so we can use normal approximation through central limit theorem. They're both 50, so using 10% condition, we both get 500. I don't care how you write this one. You can technically write it two different ways. You could either say, assuming there are at least 500 of them who have been given this one, and at least 500 who have been given this, or you can say it is like theoretically, there are at least 500 of these different types of people who could have gotten this one, and at least 500 who could have gotten the new one. And I don't care if you say it is they actually got it or they could have gotten it. Either one of those is fine. Do the way I wrote it, you would get a test statistic of negative 3.922. If you had your direction switch, then you would just have positive there. And you get a really small p-value. What does this one look like in your calculator when you do it? 9 point something what? What's the end of it look like in your calculator? Negative what? So just a reminder about what this is. So if I have something that says 9.0, this is scientific notation. So we take this and move it 1, 2, 3, 4, 5. So if this says e to the 5th, how many zeros are in front of that? 4. So it's however 1 minus that zeros in front of your number. And that's a really, really small p-value, which means we reject the null hypothesis since the p-value is less than alpha. We do have enough convincing evidence that I would just write the alternative hypothesis there. Questions with homework?